Hi, if you're seeing these solutions on YouTube, click on the description below, take these as a test and then check out the solutions for free.
AB is parallel to DE. Find the value of X. Wonderful, 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 fabulous question. When there are two parallel lines, it doesn't look like they are cut by a transversal. When AB goes like this, DE goes like this. So we know that whenever there are two parallel lines and we cut them by a line, we have a bunch of properties. We have alternate interior angles, we have alternate exterior angles, we have corresponding angles. All those things we can do. We have co-interior angles that happen to be supplementary. We can do magical things once we have a transversal. But here we do not, it doesn't look like we have a transversal. We don't have a line cutting AB and DE. So what do? We can do one of two things. We can extend AB and extend DE and then see when we extend it, do we have a common line? Or better still, we can create a third parallel line, a line parallel to both of these, and then see if we can come up with some transversal. So I can extend this and then see if that takes us somewhere. That is a possibility. Or we say, can we draw a third line that is parallel? Should be the best possible third line would be this line. Draw a line, say PCQ, parallel to AB and DE. Remember, AB and DE are parallel to each other. So any line parallel to one of these lines will be parallel to the other also. So AB is parallel to DE, PQ is parallel to both of them. Now life becomes simpler. So this angle is 110. We can find this angle. And so that is 110. What is this angle? DE is parallel to CQ. This is 110. This should be 70. DE and CQ cut by DE and CQ cut by CD. These two are parallel. If this is 110, this should be 70. Why 70? Angle DCQ plus angle CDE equals 180. Why? Because they are co-interior angles, therefore they'll be supplementary. This is 70, this is 70. They add up to 140. So these two add up to 140. What is X? Think about it. AB parallel to PQ. Parallel to PQ. There's a transversal BC here. This angle is 140. What will be this angle? That will also be 140 because they are, what is the term here? Parallel lines cut by a transversal. They're alternate interior angles. This is 140. This will also be 140. X is 140 degrees. Or we can say this is 140. This is 40. These two are co-interior angles. Supplementary. We get to 140 degrees. Wonderful, wonderful question. Whenever there are two parallel lines and there is no obvious transversal cutting them, then do one of two things. Either extend one or both lines so that you are stretching them out. Any line that cuts one will automatically look like, it will look clearly that it's cutting the other also. So you can pick transversal or draw a third line. Draw a third line that is parallel to both of these. That will open up some transversals where we can apply our set of alternate interior angles, alternate exterior angles, co-interior angles, corresponding angles. That terminology, those set of parallel line properties, we can bring them to play. And geometry is like a puzzle. There's no obvious direct way of getting to the answer. Go step by step, find whatever you can find, keep adding it to the diagram, and then look for some new property to keep adding on.